electric field along the axial line of the dipole. So first let us see what is dipole. Dipole is nothing but two equal and opposite charges, which is plus q and minus q, and they are separated by a small distance. Here we are taking 2a, is known as dipole. I repeat, two charges we are taking, one is minus q, another one is plus q, which are equal in magnitude, but they are opposite. That means one is plus q, another one is minus q. Two equal and opposite charges, and we have taken a distance between the two charges, which is nothing but 2a. So whenever the two equal and opposite charges are separated by a small distance, that is known as dipole. And here we have taken the distance as 2a. So I took a dipole. And next we are going to see about the electric field. When the test point is taken along the axial line of the dipole, this is the first derivation of your class 12 physics. So go through all the derivations of, just work out. This is the time to practice all the derivative part. Just start working on it. And first, the electric field is measured along the axial line of the dipole. This is what the derivation part which we are going to see now. You can see the diagram here. I took a dipole which is separated by a small distance, which is 2a, and from the center points the minus q is located at the distance a and plus q also located at the distance a. So together if you see, it is 2a. Between the minus q and plus q we have the distance 2a, and the test point C is taken from the center of the dipole at the distance r. R is the distance between the center of the dipole and the test point. Test point is nothing but C. So here we know the distance A, and from the center minus A. What is the distance here? R minus A. And from the minus Q, if you see, the test point is located at the distance R plus A. Remember? R. This is R and this is A. So what is the distance? This distance is R minus A. This is R. This value is A. So what is the total distance from the minus charge? It is R plus A. And this is C is known as the test point. So from the test point, if you see, E plus Q vector will act away from the plus charge, and E minus Q vector will act towards the negative charge. Always we take test point, and at the test point we always think that the plus Q is located, plus Q is kept. So plus Q, always we are taking the plus Q as a test point. So plus and plus will get repealed. So E plus Q will get away from the plus Q, and here plus Q and here minus Q. So both will get attracted. So E minus Q is acting towards the minus Q vector. And depends on the distance which magnitude will be greater. As you know very well, whenever the distance increases, magnitude start decreasing. So E minus Q magnitude will be lesser than the E plus Q. Although it's not a point, you can see the line in the book also, textbook also, it is given clearly. Whichever is lesser in magnitude or given with the short length, and whichever is larger, they used the lengthwise they have increased. Okay, so that you can show, because that gives you a concept how it is. Then we know very well the electric field of a point charge is given by E is equivalent to 1 by 4 pi epsilon naught q divided by r square. I am giving you the magnitude value. E is equivalent to 1 by 4 pi epsilon naught q divided by r square, the electric field of a point charge. What is E? E is known as electric field. 1 by 4 pi epsilon naught is your constant, which is nothing but K. Q is the charge, and R is the distance between the test point and the charge. This is a general value. And here for the positive charge is located at the distance R minus A. So what is the value? E plus Q is equivalent to 1 by 4 pi epsilon naught plus Q divided by the distance between the positive charge and the test point, which is nothing but R minus A square. So E is equivalent to 1 by 4 pi epsilon naught Q divided by R minus A the whole square. It's a vector value, so here I have mentioned like R cap. And for negative charge if you see, here I am having a negative charge, and the distance between the test point and the negative charge is given by R plus A. So what is E minus Q? 1 by 4 pi epsilon naught minus q divided by r plus a the whole square. So I got the value of electric field for positive charge and electric field for negative charge. According to the superposition theorem, we have to add both the values. So take your E total, which is nothing but E at the test point, which is along the axial line of the dipole, which is located along the axial line of the dipole. So E total is given by 1 by 4 pi epsilon naught q by E plus. So r minus a the whole square minus E minus q, which is nothing but 1 by 4 pi epsilon naught minus q divided by r plus a the whole square. I have added both the values, which is nothing but superposition theorem. Superposition theorem is nothing but add the individual electric field value to get the total value. So I have added. Then next, take the common one. Whichever is constant, take that value common values. Q divided by 4 pi epsilon naught 1 by r minus a the whole square minus 1 by r plus a the whole square into r cap. Then take LCM, cross multiply. Here r plus a the whole square, which is nothing but r square plus a square plus 2ra. And here r minus a the whole square, I multiplied with the minus also. So minus r square minus a square minus into minus plus 2ra divided by a minus b the whole square into a plus b the whole square, which is nothing but a square minus b square the whole square. So here r square minus a square the whole square, r cap I took out. So what is the value? If we cancel, r square will get cancelled, a square will get cancelled, so I will get only q by 4 pi epsilon naught 4 ra by r square minus a square the whole square into r cap. And this is very important condition, which is nothing but r value is very high comparing to the a. A is nothing but from the center where one of the charge is located. From the center of the dipole to one of the charge. It may be a plus or minus. So this distance is a. And the r is a distance between the center of the dipole to the test point. So comparing to this r, a value is very less. This is very important. Comparing to the r, a value is very less. So when you take r value, when you consider that condition, that is r is greater than a, this a square which is in the denominator can be neglected. So neglect the a square. So what you will get? E total is equivalent to q divided by 4 pi epsilon naught 4 ra. A square will get neglected. So r square the whole square. Then multiply, you will get r power 4. Divide this 4 ra into 2 ra. Keep this q by 4 pi epsilon naught as it is. Then r and r power 4 will get cancelled, which is nothing but r cube at the denominator. 2 into 2a divided by r cube, q by 4 pi epsilon naught, and here r cap. Now take the q inside and take the 2. I just separated the 4 into 2 cross 2. So 2 divided by 4 pi epsilon naught 2 qa into r cap divided by r cube. And we know very well the dipole moment. Dipole moment is given by one of the charge into distance between the two charges. Dipole moment for the dipole is given by one of the charge value, which is nothing but q, and the distance between the two charge, which is nothing but 2a. So q into 2a gives you the dipole moment, as it is also a vector quantity. I mentioned here r cap. So 2qa r cap will be equated to p vector. So 2 divided by 4 pi epsilon naught into p vector by r cube. So which can be in general equation like 1 by 4 pi epsilon naught 2p vector divided by r cube is the E vector for dipole when the test point is taken along the axial line. Here we did the derivation when the test point is taken along the axial line of the dipole. So what is the value? For a point charge, it is 1 by 4 pi epsilon naught p q divided by r square, and for dipole 1 by 4 pi epsilon naught 2p vector divided by r cube. Thank you.